This video is about using trigonometry to find angles. Trig functions like sine, cosine, or tangent have an input of an angle. So we always take the sine of 30 degrees or 70 degrees, and the output is a ratio. So the input is an angle, and the output is a ratio, and it's frequently represented as a decimal, though not always. There are some angles that work out very nicely, like the sine of 30 degrees equals 1/2. More frequently, we have these not so pretty angles or inputs. A note about entering these on your calculator: you want to make sure that your calculator is in degrees. Either the screen should display a DEG for degrees, or you can go to Mode and select degrees from there. Notice there's the primary trig function should be on any scientific calculator, but the reciprocal trig functions like cosecant, secant, and cotangent are not on your calculator. So first, let's do a primary trig function. We want to find the sine of 21 degrees. So I'm going to enter in sine and then 21 or 21.0, and I'm going to round that to 4 decimal places. I got that this is 0.35836, so that means I'm going to round that 3 up to a 4, and there's my answer. If we want to find a reciprocal trig function like the cosecant of 56.1 degrees, I first have to figure out what that cosecant is. I remember that cosecant matches with being the reciprocal of 1 over sine. So this is the same thing as saying this is 1 over sine of 56.1 degrees. And now on my calculator, I can figure out what the sine of 56.1 is. This is 1 over 0.830012. I'm just going to actually leave it at 0.83. So 1 divided by 0.83 equals 1.204819. I'm going to round it to 4 decimal places, which means that's the answer. Well, that was when we're given an angle, we could just plug it into our calculator with the trig function, but we can't do that directly with this. If we are given the ratio and we want to find the angle, we have to use something called an inverse function. The way an inverse function works is it undoes the original trig function, so we can solve for just a. Notice this tangent is not multiplied in. It's not the tangent times the angle, because we can't think of tangent as its own thing. It's always tangent of some angle. We're going to use the inverse function, which looks like tan with a -1 on it. This is not reciprocal. One tangent with a -1 does not mean cotangent. But if I take tangent of -1 of both sides, inverse tangent of tangent leaves us with just the angle A. If we were looking at this on a circle, we might have to be a little careful about the domain, but for now, inverse tangent of angle A just equals angle A. And then the inverse tangent of this number, this is something we can plug into our calculators. You should have a button on your calculator that has this inverse function. So I'm going to press inverse tangent, parentheses, 0.2126, and then close my parentheses. I ended up finding that A equals 12.00238. So I can say with pretty good certainty that angle A is 12 degrees. Again, remember that what you're taking the trig function of is an angle, and what it equals is a ratio. Let's do a problem. I want to find the measure of each acute angle given these two sides of a right triangle. I'm going to call this side A, so that's 3.2. So by convention, the angle opposite that is angle A. And then this is side 2.0, which means, again, by convention, the angle opposite it is angle B. This means the remaining two sides, angle C and side C. What we're interested in is finding the measure of angle A and the measure of angle B. From the perspective of angle A, I notice that the opposite side is 3.2 and the adjacent side is 2.0. Which trig function has to do with opposite and adjacent? Tangent has to do with the opposite and adjacent. So the tangent of angle A equals the opposite side, which is 3.2, divided by the adjacent side, which is 2.0. And I know that because I know that the tangent of some angle equals the opposite over the adjacent. 3.2 divided by 2.0 is 1.6. So the tangent of angle A equals 1.6. Now, to take the inverse tangent, when I take the inverse tangent of the left-hand side, we're left with just angle A. And on the right-hand side, we have inverse tangent of 1.6. This is something I can enter in my calculator. And I found that angle A equals 57.9946, and so on, degrees. If we round that to the nearest tenth of a degree, we end up rounding this up to 58.0 degrees. Now we could do the same thing when trying to find angle B. We could start at B and figure out which one was the adjacent and which one was the opposite, use inverse tangent again, but there's a faster way. Since I know that the sum of the angles in a triangle equals 180 degrees, I can just add up all of the angle measures. A is 58 degrees, B is what I'm trying to find, and C is 90 degrees. Now I just subtract 58 and 90 on both sides, and I find that 32 degrees equals angle B, or 32.0 degrees if I'm consistent with rounding. Thank you.